We're going to start with the less commonly used types of barrel tumblers. One of those probably looks familiar. All right. A tilting tumbler both spins and can tilt at different angles, so you can get different action. That's why we have it, so you can move it. This type of system is somewhat used in reducing the tumbling energy by angling it up, so you can soften the load just by the way the angle it's on, and then soften the aggression. Tilting tumbler can also be used without a cover, like we typically sell, or with covers. Most of the time people don't like covers because it's so easy just to reach in, pull out. It's used a lot for like what you're doing, a lot of these part-on-part tumbling. So people they reach in, reach out. And they like that, or if it's big chains and stuff that need to get, so they had to drop big chains in. That was just the easiest way to pull them out. So these are commonly, not to be surprised when people call these cement mixers. So a lot of times people will buy cement mixers and think that they could put in all the weight and it's going to last, and then they just kind of go through them once a month, and then they end up buying.
Then they change the barrels once a year, right?
Yes. Obviously it looks like it's something we all know, but much more robust, as you can obviously now tell. Some of these units will put in these probably up to 1,000 pounds, maybe a little bit more.
A little bit more sometimes, yeah.
But we've built equipment that you can tumble 2,500 pounds. Shafts, and with that, it's not really the tumbling that's the issue; it's the stopping without killing somebody that's the issue. So that we had to go through and figure that out with brakes. Because moving a 1,500 pound barrel and a 2,500 pound load and get it to stop where you want it to. Yeah, a centrifugal barrel finish machine is a high energy system. These are a little bit newer, a little bit more expensive, but in addition to having a single barrel rotating, this whole carousel rotates. All right, so you get huge energy in the machine. So you can cut down something from, that might take 2 hours to 20 minutes in that piece of equipment. Problem with that equipment is that you can't get really, really big on it. So it's good for a lot of for smaller parts. Like you can't put in, the biggest one we saw maybe is that. And the barrel's about that big, so that limits you with your parts.
The barrels probably don't get much bigger than what you see in here.
So generally, the high energy equipment is really, really good for getting a mirror-like finish. The problem is, like I said, you can't put big parts in there, and it does cost more than something like this. Obviously, so much more engineering on there. The drawing there will show you actually how tumbling action inside a barrel works. Steven's going to show you the cascading effect and how parts and media slide together to create the desired finish, and we're going to describe how the hexagon barrel actually makes that happen. And he's going to talk about the 50%, 60% capacity on a barrel. So you have a 90% work capacity. This is about 50 to 60% working capacity. So when you're sizing the equipment, you have to take that into consideration. So if you need to do X number of cubic feet of parts, if it's going to be different size machine for each. 3 cubic foot machine here as opposed to there, you're going to have half the amount of working that you would in here.
So the tumbling action is basically the same whether you're using a vibe or a barrel tumbler. But what happens this is a barrel. So as this barrel rotates like this, these angles on the barrel will help to kind of lift up the load, and then it slides back down. So it's going to come up a little bit to about 80 or so percent of the side and slide back down. So as it slides, all the media is working against the parts to kind of sand them down or polish them or whatever the process is that you're using. So in a vibratory machine, and we'll talk about this later, but the same kind of a thing is you're going to see everything kind of tumble around just like this, like you see here, but around this, like a center axis.
It's exactly what we saw yesterday.
Yeah, exactly. Right. So we saw that yesterday. In a barrel, what you want is you want more media than parts typically. Not always, but typically, because you don't want the parts banging into or impinging on each other, or else they'll start to damage each other. With larger or heavier parts, you're going to even want a higher percentage of media because the parts are always going to figure out a way to find each other. They're friends before, they want to hang out together, so they're going to find a way to bang into each other.
Yeah, so like I said, there's times for really sensitive applications. You'll have a 20 or 40 to 1 media to parts ratio. That's the real sensitive and critical parts. Parts like what you're doing, in those things. I mean, if you were to throw a media on there, if you did a 1-to-1, you'd be fine. You're just adding abrasive into the process if you don't really care what the surface looks like and you're just trying to break edges.
There are some times, and this is typically done, or almost always done in a barrel tumbler, where you're doing not laser, plasma cut parts. You can get some really heavy slag on the edges of those parts, and you would do almost like a part-on-part process. So really, it's not so much an abrasive process as each part is just kind of knocking that slag off. The parts come out looking terrible, but if you don't care, or if you're going to coat them, or if they're an internal part, it's a super easy way. And you want to talk about loud? I mean, that's loud.
Yeah.
We would put liners in for people that are doing part-on-part tumbling just to dampen the noise.
Right.
Because that's another benefit of the liners. It absolutely quiets the process because it can get grating.